Today we're going to be talking about two different types of symmetry. The first one deals with even functions. Even functions are going to be functions that have symmetry to the y-axis. So two functions that you've seen before that have symmetry to the y-axis. One of them would be a parabola. Another would be an absolute value. If you use the y-axis as your symmetry, if you were to fold these functions in half, they would have symmetry with the y-axis. Those are even functions. Odd functions are going to have symmetry with respect to the origin. So two functions you've seen before that are odd are cubic and various linears. Their symmetry is all with respect to the origin, which of course is that point 0, 0. So there's ways to test for even functions and for odd functions. Using the graph, you can tell by the picture usually, but it also helps to have an algebraic way if you do not have the graph in front of you. So here's a parabola, which I said on the first slide is an even function. The way to actually test for an even function is f of negative x equal to the same thing as f of x? Well, if I pick some x value, and I look at its y value, f of x, then I plug in that same x but in the negative direction, do I get back that same y value? The answer is yes. You can do this anywhere along your graph. If I plug in this x value, I get back this y. If I go that same value but in the negative direction, I get back this same y value for both. So that's a way to test for even functions. To test for odd functions, we're looking for that symmetry with the origin. Again, I said a cubic function is a good example of an odd function. Okay, a cubic one centered at the origin. This time, when I plug in negative x, I'm asking myself, is that equal to the opposite of what I got the first time? So again, if I plug in an x value, I get back my y value, my range. So now if I go x in the negative direction, do I get back this same y value, but in the negative direction? And the answer is yes. So going over to the right and then up, do I get the same thing as when I go over to the left, going down? That's how you're going to test for origin symmetry. So here we have the question, is the function even, odd, or neither? Because sometimes a function doesn't have symmetry, and that's okay too. So first thing we want to remember is our test for even, f of negative x, is it equal to f of x? In odd function, we said is f of negative x equal to negative f of x. So in order to compare all of these, we need to have f of x, which in this case we do, it's g of x. We also are going to need to have f of negative x. So let's go ahead and find that. So if you remember from our intro to functions, we're going to plug in a negative x everywhere we see x. That all simplifies to negative x to the third minus 1. And then we're also going to need negative f of x. So in this case, negative f of x is going to be negative x to the third minus 1. I'm just taking negative of this. Alright, so now let's go ahead and compare them. Is f of negative x, is this right here equal to this? No. So that means it's not even. Is f of negative x equal to negative f of x? The answer is no. So it's not odd either, in which case this function is neither. Looking at this function over here, again, we need basically three different interpretations of this. We need f of x, which we have. We're going to need f of negative x. This is where we need to recall a little bit of our previous algebra. X to the 4 thirds, remember that represents the same thing as the cubed root of x to the 4th. You're raising it to this power and taking this root. So f of negative x is going to be the same thing as 6 cubed root of negative x to the 4th minus 5. Simplifying, we know that negative x to the 4th is really just x to the 4th. So negative times negative times negative times negative gives you a positive. So we've got this one taken care of. The next thing that we're going to need is negative f of x. Again, this just means the cubed root of x to the 4th, so I'm going to rewrite it that way. Distribute in that negative sign, you get a plus 5. So now let's do some comparison. Is this right here the same thing as our original? Yes, it is. So this function is even. Should also just double check, just to make sure, is this the same thing as our original? The answer is no, which means it's not odd. Now, your instinct should tell you if a function is even, it's not odd. All right, we're going to do a real quick review just to make sure you have the concept, so when you plug in that negative x, you know how to simplify things. First one says find f of negative 3. Well, that means that everywhere you see an x in your function, you're going to replace it with a negative 3. Negative 3 squared makes a positive 9. This will be a positive 9 plus 1, so we get 19. So when you put in negative 3, you get back 19, input, output. F of x minus 5 means that everywhere you saw an x before, you're going to replace that with an x minus 5. Now, don't forget that this requires foiling. So we're going to do some first, outside, inside, last. And distribute in this negative 3. And now do some simplifying. So I've got x squared, negative 10x and negative 3x is going to give me negative 13x. 25 and 15 gives me 40, 41. All right, that one's not really listed as a coordinate point, but that is what you would get if you plug in x minus 5. Over here we have a graph g of x. This is asking for g of negative 3. So when I put in negative 3, what do I get back out? I get back out negative 1. When I put in 1, what do I get back? Looks to be about 6. Just a little reminder for how to deal with functions.